All right, so I just wanted to do a quick little overview on what is a projectile and projectile motion as you're getting ready here at the end of the unit. So just remember, a projectile is anything that's traveling through the air, where the only force acting on it is gravity. Now what this means for us, if we take a look here, is that an object would move horizontally as if there was no gravity. So it would move out evenly spaced each second. But vertically, gravity is going to accelerating, meaning it's going to travel more and more distance each time. If you put this all together, what happens is the object travels in a nice parabolic shape. Key things to remember here: in the x direction there is no acceleration, so the velocity remains constant, while in the y direction the acceleration is always going to be gravity, which is negative 9.8 meters per second every second, meaning the velocity is changing. The only thing that does remain the same in both directions is time, and so we can use that to help going through here. Now here's some tips to help us remember about projectile motion. Projectile motion in the x direction, like we said, velocity is 0, or acceleration is 0, so velocity stays constant. In the y direction, there's always 9.8, and therefore it's changing. To do the problems, you need to split them up into their x and y components. And so in the x direction, it's typically going to look like this, where you have your velocity in the x, your distance in the x, and your time. Notice that I didn't put velocity initial for the x direction or velocity final, because remember, it doesn't change, so there is just one velocity for the x direction. In the y direction, though, we do have 5 variables we would have to solve for or could know, and that is that gravity is negative 9.8 meters per second every second. And the initial velocity, if possible, we want to set it up where the initial velocity is equal to 0, because what this does is it makes it easier to solve problems. Remember, when you take a look here, when something gets shot horizontally, like I have in the first picture down at the bottom, the velocity in the y direction is going to be 0 when it first leaves there. So I should call that velocity initial. The only variables we could mess with or change is how fast it's moving horizontally, how high up it is vertically, or how far it's going to go horizontally. You may have a projectile that goes up and then gets launched to the side, like I did here in the second picture. And remember, the way to solve this problem is to take a look and remember that at the top, it's only going to be moving horizontally. The velocity at this point in the y direction is 0, and we can use that fact here to add another variable if possible. The key thing to remember is the time it takes to get to the top, or if you want to do it the other way, the time it takes to get down. That is only going to be half the total time that the object is in the air. So just keep that in mind, that sometimes that can mess us up. All right, let's take a look over at the handy equations to remember. Number 4, the Fantastic Four, is the one that is the most valuable to us. We use it all the time. First part to realize is if in the in the x direction, if the acceleration is equal to 0, what happens is the second half of that term disappears, and what you're left with is just this part right here. So the v initial t, that is the x part of the equation. If you can, set it up so that the initial velocity is 0 in your problems, then what happens is that first term can drop out, and what you're left with is just the second half of the equation there, and that works for just the y direction. Now I do have it listed as delta x, but realize that just means displacement, and it could happen vertically or horizontally. 2 other equations that are helpful for us to have around are just simply the definitions for velocity and acceleration. Now remember, you would only use velocity, the constant velocity equation, in the x direction. You wouldn't use it in the y, because the acceleration would be causing it to change. And there is no acceleration in the x direction, so you wouldn't use the definition for acceleration in the x direction. You'd only use that vertically. Now this one's a little time saver here, the one we have here where it says if. It works only if the initial velocity is equal to 0. So I can't stress that enough. If it's not equal to 0, then it's not going to work. But if the initial velocity is equal to 0, then we can do ourselves. We can take that number 4 and we rearrange it a little bit, and we solve for t, which we often have to do is to find that time. It turns out that time is equal to the square root of 2 times the height, all divided by the acceleration, which would be 9.8. If you do this, it can save you a bunch of time when doing your problems. You don't have to do a bunch of little algebra afterwards, but it's only if in this one little situation where the initial velocity is equal to 0. All right, now let's go down to the next one. You're going to have to use problems from time to time that are going to require trigonometry. So we got that right here. We got a projectile that's being launched at some angle like so. If you use SOHCAHTOA to help you out, it turns out that the velocity in the x direction is equal to the velocity times the cosine of the angle, and the velocity in the y direction would be equal to the velocity of the times the sine of the angle. Like I said, this can really help us out when you're trying to do trigonometry. And one more time, we'll put that down. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Last thing you need to remember is when we're doing these problems, there's often a lot of back and forth. If I ask you about something in the x direction, like for example here with the lava monster problem, the whole point was to figure out the distance in the x. The way to actually solve the problem is to start over on the other side. So if I ask you to find something in the x direction, you're probably going to have to start your calculations over on the y. That's about it. So hopefully this works out for you. It was a nice review of everything on projectile motion. Go through your notes, work through the sample problems, and don't forget there are other videos with other instructors that go through this, and maybe one of them is saying something that makes more sense to you than I did for you. Good luck, and we'll see you later.